Okay, in this video I'm going to go over common mistakes that students do usually and I have observed in my practice. So let's start with 5x squared. When we are squaring term with like 5x, we have to square every single element in that term, meaning 5 squared, x squared, and as a result we will get 25 x squared. And instead they leave 5 without raising to power, and they raise to power only x. Okay? Next one, negative 3 squared. Negative 3 squared, it differs from if we have negative 3 in parentheses squared, because that means the base here is negative 3. In this case, the base is here only 3. So negative 3 you can interpret as a negative 1 times 3 squared, because it's not included in parentheses, okay? Therefore, negative will stay outside, 3 times 3 is 9, and negative will move on the other end. All right? Okay, and instead, some students get confused, and when they see negative 3 without parentheses, they still use the base negative 3 mistakenly, and they get positive 9. The next common mistake is when they open parentheses and in front of parentheses is negative, they just flip the sign of the first term, and the rest they don't touch it, just like here they have. And instead they have to flip every single term that is in parentheses. Look here, 3x is positive, became negative, 2 here is negative, became positive. That is another common mistakes that students usually do. Next one, see again, it's similar to this 5x squared, the square root of 11x. They just leave out 11 and only take care of x over 1/2. Instead, it has to be 11x, entire 11x has go under 1/2 exponent, because 11 with x is also under 11 under square root. So it should be 11 to power 1/2, x to power 1/2, which will be equal 11x to power 1/2. Okay? All right? Let me clean this. Okay. Next common mistake is also, again, let's say 3 times 2x minus 5. They distribute only on 2x, and minus 5 they leave alone. So it's, as we noticed practically, it's in several examples I showed you, they apply operation only to the first one and leave out of it the rest. Okay, so it should be 3 times 2x, 3 times negative 5, 6x minus 15. The other problem is it's very, very common. For example, 5x, this one, 5x minus 6 over 2. They take this 6, rip off from 5x minus 6 and the reduce with 2. You cannot do that. You do not dare to do that, because this 2 belongs to 5x and this 2 belongs to this 6. If you want to cancel it, 6 and 2, first of all, what we want to do, we're going to separate 5x over 2 minus 6 over 2. And we get 5 over 2x minus 3. Look how different it is. Here, this 2 is standing as a denominator for 5x. Here, 5x, all of a sudden, in this case, denominator disappeared. Okay? So be very careful. If you have addition and subtraction, let's say, I don't know, let's say 3x plus 1, or the 2x minus 1, and you have in denominator something there, you do not dare to pull apart, because they have to be treated as one whole. Hold on. Let's say here is 2 and here is 3. You cannot cancel like that. You need to break them down just like here, okay, with the same denominator, and then cancel it. All right? Okay. Next one, 5 over 2x. Yeah, this is also a common mistake I have seen so many times. Look here, 5 over 2, gee, I keep taking different color, very thick. 5 over 2x, meaning 5 over 2 times x. Yes? When we multiply, what do? 5 over 2 times x over 1, which means 5 times x and 2 times 1. And we get 5x over 2. So, from here we can say that 5 over 2x, it's the same thing as 5x over 2. But you cannot write down 5 over 2x. Why? Because in this case, it looks like 5 over 2 divided by x. Let's divide, we'll see. So if I take 5 over 2 and divide by x, it's going to be 5 over 2. I'm flipping this x, like, will be times 1 over x. And we get 5 over 2x. Okay? But we cannot write in this format because it's division by x. And we have here multiplication. Are we clear? So you can either write down 5 over 2x, or x can go on the top to numerator, but in no case it can go to denominator. All right. Let me clean this mess. Next one. This is it's a little bit can be confusing and tricky. So why, when we are taking square root of 25, it has to be positive 5, but when we take square root of x, or the x squared or square root of y squared, doesn't matter, we get a module of y. Let me explain. So when we have 25, it's a number, right? And we know the number under the square root, it's always going to be positive. So there is no way you will get negative 5, because it's clear that we have this number, it's 5. But when we have variable y squared, we have no clue what y is. Y is positive, y is negative. Okay? In that case, it's going to be module, which means it is plus minus y. So every time, wherever you see variable under square root, okay, you're going to end up with plus minus. Okay? Plus minus that variable. The second one here is also x squared equal 25. Let's see how we're going to solve it. So if x squared equal 25, actually I have it here, but that's okay, I'll rewrite it. X squared equal 25. So that's mean I have to take square root from both parts of equation, right, to get x. So since we have x variable, it's going to be plus minus x, correct? And 25, we know it's going to be positive 5. We just talked about it, right? And from here, since plus minus x equal 5, then x is equal plus minus 5. How we get? We divide. Plus minus y, or you can divide separate by plus 1 and then minus 1, and you will get the accordingly plus minus 5. Okay. So from here, x is equal plus minus 5. Okay? And here it is. You got the result. So you get plus minus only and only if you are taking square root from the variable. But if you are taking square root from the number, you always get positive 1. And writing down like this, it is absolutely wrong. Okay, moving to next one. Let me clean this. Okay, moving to square root x squared plus y squared. So because we have x squared and y squared tied up with addition, you cannot separate them and write down equal, you cannot take square root and get x plus y. It cannot happen because it has to be multiplication. In the case of addition, you cannot do anything. In this case, x squared, square root x squared plus y squared is as far as you can go. Another example of common mistake, x squared times x to 4. Some people mistakenly multiply. It is wrong because when we multiply, a to power m times a to power n is equal a to power m plus n, which is going to be x to power 6. Okay? So we don't multiply. When do we multiply? If I would have, let's say, if I would have x to power 2 raised to power 4, then I had to multiply because I have power to power. But when you have two bases and you multiply these two bases, then you add these exponents. Okay? Next one. 2x to power negative 1. A lot of people just again the same similar mistake. X goes to denominator. They put as the 1 over 2x. It's absolutely wrong. 2 times, let me show you. 2 times x to power negative 1 is equal to 2 times x to power negative 1, right? Which means 2 times x to negative 1, meaning 1 over x, correct? And that means if you multiply, so denominator of 2 is 1, so it's going to be 2 times 1, 1 times x, or it's going to be 2 over x. Okay, and we have here 2 over x. All right, next common mistakes, let's look at it. I truly hope that this video will help you to clear up all these casual mistakes that students usually do. Next one, a plus b over c plus d. So they take and write down in this notation. You know what that means, this type of notation? That means a plus b over c and plus d. Because when you don't have parentheses, they take only, the math will take only this division, and that's it. And the a and d will live as whole numbers, separate numbers. This is what the correct format for it. A plus b, because they are together, a plus b. You can't separate a plus b. You put them in parentheses. And you can't separate c plus d because in the case of multiplication and division, plus or minus, terms that connected to each other is a plus and minus, you cannot separate them. So, and divided by c plus d in parentheses, this will be just it's the original format, a plus b, c plus d. Okay? Next common mistake, logarithm a plus b is equal log a plus log b. Just like during the fraction, when you have two terms added to each other or two terms subtract to each other, they are tied up. You cannot pull them apart to cancel or do operation. The same way is log. You have a plus b. You cannot separate them, log a plus log b. So, and you cannot do any changes. Okay? You could get, let me see, you could get log A plus log B only and only if we would have logarithm AB, which would be multiplication. Then that will be log A plus log B. Look, I put in parentheses log ABY. Otherwise, if I would write down, let's say, log A and B, that would can be interpreted logarithm A times B, and B would have nothing to do with log, but it's wrong because B is supposed to be under the umbrella of logarithm. Okay? All right? And this one also, just like I said, when any term in the fraction tied up with addition or subtraction, you cannot pull them apart. You cannot write down x over x plus x over y. You can separate them when x plus y will be on the top and x will be at the bottom, because you cannot split denominator that connected with addition subtraction. So that's a different story. X over x plus y over x. These x's will be gone and you will have 1 plus y over x. That is perfectly normal because they have common denominator. So everybody using their common denominator. But here you take a separate, you are changing denominator. You cannot change denominator. Here we can do that because I did not change denominator. I just separated in numerator with their common denominator. Are we clear? Okay. So in the next one, here I put it down, you cannot, it's write down x plus y squared equal x squared plus y squared. Or see again, under it's plus under square root, you cannot separate them, right? Only you cannot do that. Only if you would have, let's say, square root of xy, you could write down square root of x times square root of y. That would be a different story. It's multiplication. And the same similar mistake is when you have 2 plus 5 squared, you cannot write down 2 squared plus 5 squared. Why? Because let's check it. 2 plus 5 is 7, squared is 49. Now let's do 2 squared plus 5 squared. It's going to be 4 plus 25. It's equal 29. All right? Okie dokie. Thanks for watching, and I'll see you in the next video. Bye for now.